Hello my friends and welcome back to the You Can Do TV channel. The WPS-62I placer spreader played a decisive role in the Conroe, Texas CRCP project, serving as the lead machine in Wirtgen's first ever full-line paving train for continuously reinforced concrete pavement. Engineered for controlled, high-volume concrete placement, the WPS-62I delivered uniform material distribution across the 7.9-meter-wide formation, ensuring consistent feed to the downstream paving and curing systems. Its wide conveyor belt, precision metering and responsive hydraulic controls maintained a steady concrete head, which is critical for CRCP applications, where continuous steel reinforcement and slab continuity demand exceptional accuracy. The machine's maneuverability and fast setup minimized idle time between cycles, supporting uninterrupted operation along the 3.8-kilometer alignment. Integrated sensing and automated strike-off adjustments further optimize surface uniformity before slipforming. As a result, the full paving train achieved a 40% productivity gain and delivered the roadway 1 week ahead of schedule. The successful performance of the WPS-62I demonstrated the operational advantages of a fully synchronized Wirtgen paving system in high-specification, heavy-duty pavement construction. The B313 Stockhack pilot project implemented the CRCP asphalt system to enhance road durability and sustainability. The process began with precise surface preparation, ensuring proper grading and cleaning of the existing pavement. CRCP asphalt, an innovative air-void optimized mix, was applied using specialized paving equipment to achieve uniform compaction and density. The technology reduces material consumption while improving skid resistance and load-bearing capacity. Continuous monitoring with rollers and sensors ensured optimal compaction throughout the paving operation. This pilot demonstrated CRCP's potential for extending pavement lifespan, minimizing maintenance, and supporting eco-friendly road construction practices, setting a benchmark for future sustainable infrastructure projects. The Erasmusland Square paving in Zwolle is efficiently carried out using the Pleinenleger, a specialized paving machine. The machine lays paving stones accurately along the prepared surface. Once the paving area is full, the operator can advance the machine by pressing the foot pedal, allowing continuous operation. The Pleinenleger maintains perfect alignment thanks to a side-mounted sensor that ensures the machine stays square to the paving line. It moves over a carefully leveled base, ensuring uniform placement of the stones. Tracks under the machine allow it to travel smoothly without disturbing the freshly laid surface, preserving the integrity of the completed section. This method significantly improves efficiency, reduces manual labor, and ensures precise, professional quality paving for roads, squares, and other hardscaped areas. The Vögele Super 3.000-3I set new standards in road construction during the resurfacing of the A96 near Lindau at Lake Constance. Over a stretch of 6.8 kilometers, both the base and binder layers were installed, requiring traffic to be redirected to the opposite carriageway. The Super 3.000-3I, one of the largest road pavers in the world, delivers up to 1,800 tons per hour, with a maximum paving width of 18 meters and a maximum layer thickness of 50 centimeters, making it ideal for large-scale projects. For this project, Cutter GmbH & Co. Kilogram utilized the Super 3000-3i with the new rigid Vögele SP 350 screed, featuring a 3.5-meter base width and stiff cross braces that ensure perfect surface evenness and pre-compaction. The hydraulic tamper adjustment allows operators to set compaction depth between 4 and 8 millimeters with ease. Pre-compaction of the 14 cm base layer was achieved using the high compaction screed plates, ensuring a smooth, level foundation for subsequent layers. Material supply was maintained by two Mount 3000-2 offset feeders, each receiving sequential deliveries from trucks to avoid downtime, allowing up to 4,000 tons per day to be laid almost dust-free. The Ergo Plus 3 operator platform gives full control and oversight, while the dual Vögele sensor system automatically detects and corrects long surface irregularities. Powered by a 6-cylinder diesel engine with 154 kW, the Super 3000-3i operates efficiently, consuming minimal fuel and maintaining low noise levels. Compliance with Stage 5 emission standards, combined with the EcoPlus emission reduction package, ensures environmentally friendly, future-proof operation. This project highlights the Super 3000-3i's engineering excellence, combining high output, precision, and sustainability in modern highway construction. The Plynon-Legger paving system enables highly mechanized sidewalk and road surface installation by combining material handling, precise alignment, and continuous laying in a single workflow. First, an excavator loads palletized pavers or loose blocks onto the Plynon-Legger's feed deck, ensuring a consistent supply of materials. Workers positioned on the machine arrange the pavers according to the required laying pattern, maintaining joint alignment, bond direction, and edge geometry. Once the layout tray is fully prepared, the Plynon-Legger advances along the graded and compacted base course. Its synchronized lowering mechanism places the entire pre-arranged mat of pavers onto the bedding layer with uniform pressure, ensuring even seating and excellent surface flatness. The machine's guidance system keeps the unit perpendicular to the paving lane, while crawler tracks distribute machine weight evenly, preventing surface disturbance. This semi-automated method significantly accelerates installation speed, enhances pattern accuracy, and reduces manual strain on workers. The result is a clean, consistent, and visually seamless paved surface, making the Plynon-Legger ideal for plazas, sidewalks, pedestrian zones, and urban streetscapes requiring both durability and high aesthetic quality. Slipform paving is a high-precision concrete paving method that uses a continuously moving slipform paver to shape, consolidate, and finish concrete without fixed side forms. The focus is on the machine's controlled motion, automated grade and slope systems, and constant vibration to achieve uniform density. As concrete is fed from the front, the paver forms pavements, curbs, or barriers in a single pass, delivering smooth, durable surfaces ideal for highways and large-scale infrastructure projects. Lifting system, designed for lifting, cleaning, and repositioning floor tiles. Utilizing vacuum technology, it efficiently handles airtight materials such as floor tiles and large panels, ensuring secure and damage-free movement. The system can be connected either to a vacuum pump mounted on an excavator or to a standalone vacuum unit, providing flexibility depending on the worksite setup. The suction frame is capable of handling multiple tiles simultaneously. For example, a 12-tile model can lift 12 30 by 30 centimeters tiles at once, significantly reducing handling time. Some models are electrically powered, using lithium-ion batteries and featuring start/stop systems to optimize energy consumption. This system greatly improves efficiency and reduces manual labor on construction sites, particularly when working with tiles that have moss, grass, or other growths in the joints. By minimizing physical effort and the risk of tile damage, the Nematec vacuum tile lifter ensures faster, safer, and more precise tile placement. Its versatility and ergonomic design make it a valuable tool for contractors and workers in flooring and paving operations, enhancing both productivity and quality. Wirtgen's WPS-102I concrete placer is engineered for high-volume, precise concrete distribution ahead of slipform pavers. Its standout feature is the 62-inch wide belt, capable of handling large surges of concrete with a boost mode that increases throughput without spillage. Dual hydraulic pumps allow fast yet controlled belt height adjustment, supported by a soft touch system to prevent impact at the top or bottom positions. A remote control enhances safety and efficiency by allowing operators to raise or lower the strike-off, manage machine loading, and maneuver the unit onto trailers while maintaining full visibility. For the Plastic Road Bicycle Path project by KWS, Nematec supplied a vacuum lifting system equipped with specialized suction cups. This project marks a world first. A bike path constructed from recycled plastic. Vacuum technology works by generating negative pressure between the suction pads and the material surface, creating a strong adhesion without the need for mechanical clamps. This enables safe lifting of heavy or fragile materials, reduces manual labor, and ensures accurate placement. In the Plastic Road project, the vacuum system allowed KWS to lift and position the recycled plastic path segments smoothly and reliably, even in complex alignments. The operator uses a shovel to support the mechanized screeding process, ensuring uniform material distribution. The mobile screed unit, pulled by a chain system, levels and prepares the bedding layer with high precision, creating a consistent surface profile before the paving units place the concrete or stone elements. The Rehabilitation du Canal de Courbon is a complex, multidisciplinary hydraulic infrastructure project that combines specialized construction methodologies, precision material engineering, and continuous hydrological control. The operation starts with the livraison du matériel spécifique, including vertical finishers, trenchers, membrane welding systems, geotextile deployment units, and mobile asphalt mixing plants engineered for producing batuminous concrete adapted to steep hydraulic slopes. Before any physical work begins, laboratories undertake the mise au point des formules, establishing optimized bituminous and hydraulic concrete mixes. These formulations undergo an extensive series of essais spécifiques, validating mechanical performance, permeability, temperature stability, and adhesion under irrigation conditions. Preparatory works include the systematic nettoyage des rives, where vegetation, degraded soil, and accumulated sediments are removed to restore access and ensure lateral stability. This is followed by the controlled vidange du canal, executed through bypass valves and temporary conduits to maintain downstream supply. Once the water level is fully lowered, engineering teams proceed with the nettoyage du support, employing high-pressure washing, mechanical brushing, and localized milling to achieve a clean, adherent substrate for the upcoming sealing layers. Simultaneously, major Genie civil terrassement operations are deployed to reinforce the canal's structural environment. One of the project's most significant achievements is the foncage de trois tunnels sous le canal, each with a diameter de 1.8 meters. These tunnels accommodate new drainage conduits, monitoring networks, and future infrastructure services. Tunnel boring progresses with constant geotechnical monitoring to guarantee surface stability above the canal. Upon completion, the controlled sortie du tunnelier is executed, marking a critical milestone in the subterranean works. Material production follows strict technical protocols. The fabrication des bétons bitumineux is conducted in a dedicated mixing facility, where temperature, binder content, and aggregate gradation are monitored continuously. Once approved, these mixes are transported to the application zone. On the canal's sloped embankments, crews apply the mix over a 20 meters de talus, using a precision finisseur vertical designed to maintain thickness uniformity and consistent slope geometry. The waterproofing system is constructed as a multi-layer complex étanche. First, a structural geotextile is deployed to stabilize the support and prevent puncture. On top of this, a high-performance membrane is installed. Technicians perform sequential soudure de la membrane using thermal welding, followed by integrity testing to verify seam continuity. Integrated drain systems are placed along the slope to collect seepage, while embedded conduits carry fiber optique lines for real-time monitoring of structural movements, moisture levels, and potential leakage. A reinforced couche d'étanchéité of bituminous concrete is then applied over the membrane. This layer undergoes systematic compactage using rollers adapted for steep inclines, ensuring proper density and long-term impermeability. Throughout the operation, irrigation est maintenu through temporary bypass channels to secure water delivery for agricultural and municipal users downstream. Specialized equipment such as the trancheuse is used to open trenches for drains, cables, and monitoring conduits, completing the subsurface infrastructure. Quality control is supported by dedicated structures including the chambre de mesure and bac de mesure, where engineers perform detailed control de débit, infiltration checks, and flow calibration. Through meticulous planning, specialized equipment, advanced materials, and rigorous hydraulic engineering standards, the Canal de Curbin's rehabilitation ensures long-term durability, improved impermeability, and enhanced operational performance for decades to come. The Alcon's Asphalt Paver 6400HS, deployed on the Noctigal hydropower project in Cameroon, is a specialized high-performance paving system engineered for large canal and waterway structures. Designed to operate on steep, long embankment slopes, the machine delivers continuous, uniform asphalt placement across variable widths ranging from 24 to 36 meters. A winch-assisted carriage secures the paver on inclined surfaces, while a high-volume feeding system ensures uninterrupted material flow required for hydraulic structures. With precise hydraulic controls, automated grade regulation, and optimized compaction performance, the 6400HS provides a dense, impermeable asphalt layer essential for canal sealing and long-term hydropower infrastructure durability. The Alcon's 36 meters asphalt paver is an ultra-wide mechanized paving system engineered for large embankments, dam faces, spillways, and high-volume civil works requiring continuous, uniform asphalt placement. With an impressive 36-meter working width, the machine eliminates multiple passes and cold joints, ensuring exceptional surface homogeneity. A winch-assisted carriage stabilizes the paver on steep slopes, while the high-capacity feeding system, often paired with a material transfer vehicle, delivers a constant asphalt flow across the full screed width. Precision-controlled hydraulics, automated grade and slope sensors, and uniform compaction capabilities enable consistent layer thickness, optimal density, and high structural integrity across challenging terrain. Alcon's winch carriages ensure safe operation on slopes for road construction equipment. The WW series pulls and holds asphalt finishers or road rollers using an excavator. The WG series supports continuous embankment dam lining with high-volume feeding and material transfer vehicles. The WS service carriage features a diesel-electric hydraulic drive, suitable for working platforms and rollers, making it ideal for slope work and rehabilitation projects, combining safety, stability, and efficiency in challenging terrain. An accident involving an excavator being unloaded from a transport truck highlights the high-risk nature of machine transfers in confined loading areas. When ramp surfaces become slippery or unstable, or when the machine's center of gravity shifts unexpectedly during descent. As the excavator transitions from the truck bed onto the ramps, dynamic loads increase, making the machine susceptible to lateral tipping, especially if the ramps are not secured or positioned at the correct angle. Ground personnel standing too close to the unloading zone face additional danger from sudden machine movement or ramp failure. Before starting work, operators must complete pre-use inspections covering hydraulics, track condition, boom integrity, and safety systems such as alarms and cameras. Loads should be lifted only within rated limits, with controlled, gradual movements to prevent tipping or uncontrolled swings. When these protocols are followed consistently, the likelihood of an excavator-related accident is drastically reduced, safeguarding both workers and equipment on the construction site. The Sandvik Mount 720 roadheader is a high-capacity, crawler-mounted excavation system engineered for cutting extremely hard rock, exceeding 120 MPa compressive strength. Equipped with an electro-hydraulic drive and a telescoping cutter boom, it delivers a cutting speed of 1.4 meters per second for continuous, high-precision mining and tunneling. Its wide 4.56 meters loading table feeds a double-chain conveyor capable of moving up to 400 cubic meters of material per hour, ensuring efficient face advance. With a tramming speed of up to 18 meters per minute, the Mount 720 supports rapid repositioning. built in 2020 and located in Western Canada. The surface miner is employed for selective bauxite mining, operating continuously 24/7 with 100% blast-free methods. Using side casting, the surface miner 2500SM achieves a standard cutting width of 500 mm and a depth of up to 650 mm, with current operations cutting 500 mm deep. In the first cut, material is deposited into the trench. The second cut occurs adjacent, with the discharge conveyor swiveled to deposit material onto the side of the first windrow. Subsequent cuts, up to the 13th, can swivel up to 90 degrees, forming an in-pit stockpile. This method protects most mined material from rainfall, while in-pit stockpiles drain naturally and dry under sunlight. A 13-cut sequence creates a 31 meters wide stockpile with approximately 35 t per meter, enabling efficient loading with wheel loaders and excavators. Side casting ensures a smooth, level surface, full pit accessibility, and compatibility with highway trucks for haulage. For direct loading, the surface miner 2200SM cuts, crushes, and loads bauxite in a single operation with a standard width of 200 mm and depth up to 300 mm. Current operations reach 250 mm depth. Advantages include reducing the number of mobile machines required, streamlining operations, and maintaining continuous production of up to 5 million tons per year, with compressive strengths ranging from 20 to 50 megapascals. Both methods optimize efficiency, safety, and resource management in bauxite mining. The All-Cons Gantry winch carriage is a precision-engineered lifting system designed for safe and efficient handling of heavy loads on gantry structures. The carriage operates on a robust wheeled frame that moves along the gantry rails, ensuring smooth and controlled horizontal motion. Powered by an integrated winch system, it enables accurate lifting, lowering, and positioning of materials with minimal operator effort. Safety is enhanced through load-limiting devices, emergency stop mechanisms, and reinforced structural components to prevent overloading or mechanical failure. The carriage is compatible with various hook, sling, or lifting attachments, allowing versatility across construction, industrial, and assembly applications. Its durable design reduces maintenance requirements, while precise alignment with the gantry ensures stable load transfer and consistent operational reliability. Scale up to examine how concrete and construction technologies are applied in major infrastructure projects. The Vidalta Bridge, constructed in Mexico City by Mexpresa, was designed to span a deep ravine and connect the neighborhoods of Bosques de las Lomas and Lomas de Chapultepec. Given the complex topography and challenging geotechnical conditions, the construction process required advanced structural techniques and precise execution. The project began with foundation works, which involved drilling large-diameter bored piles to support the central inverted Y-shaped pylon. Reinforced concrete footings were formed with high-strength materials, ensuring seismic resistance and structural stability. Soil stabilization and pile integrity testing were completed prior to vertical construction. The pylon was then erected using climbing formwork systems, with each segment placed using heavy lift cranes. Parallel to the pylon erection, the stake cables, composed of high-tensile steel strands, were installed using a balanced sequence method to prevent excessive torsional loads. Once the main structural system was in place, the deck construction commenced. The deck surface was poured using polymer-modified concrete and included high-performance finishes to enhance durability. Safety barriers, drainage lines, lighting systems, and pedestrian paths were also integrated. Expansion joints and elastomeric bearings were precisely installed to accommodate thermal movements and dynamic loads. Throughout the entire project, monitoring systems including geodetic sensors, strain gauges, and real-time imaging were deployed to control tolerances and maintain alignment. BIM technology played a critical role in coordinating construction activities, especially in the constrained urban environment. The result is a signature cable-stayed bridge that blends elegant architecture with robust structural engineering, representing one of the most technically sophisticated bridge projects in the region. Bridges represent just one type of major infrastructure. Ports are another critical component that depend heavily on advanced concrete techniques. Infrastructure represents an important and growing sector for concrete construction. PECO provides advanced foundation solutions specifically engineered for onshore wind turbine installations. These solutions are highly customizable, allowing adaptation to specific project requirements by offering individual components, detailed design services, or comprehensive foundation reinforcement packages encompassing both design and assembly. The core advantage of PECO's foundation technology lies in its modular flexibility and rapid deployment, which accommodate various project scales and site conditions efficiently. The design phase leverages PECO's engineering expertise to optimize reinforcement layouts that ensure structural integrity and durability under dynamic wind loads and cyclic stresses inherent to wind turbine foundations. PECO's design solutions comply with international standards and are validated through extensive testing and finite element analyses to guarantee performance and safety. Manufacturing is executed through PECO's strategically located European production units, which maintain stringent quality control and enable prompt deliveries. The production process utilizes high-strength steel components fabricated with precision to facilitate quick on-site assembly and reduce construction time. During construction, PECO's foundation systems simplify the installation process by providing prefabricated reinforcement cages and modular elements that minimize labor and site disruptions. This streamlined assembly supports accelerated project timelines, reducing overall costs and enhancing reliability. PECO's solutions have been successfully implemented across numerous projects worldwide and are compatible with foundations for all major wind turbine manufacturers. By integrating engineering design, manufacturing excellence, and efficient construction methods, PECO delivers a comprehensive wind turbine foundation solution that meets the evolving demands of the renewable energy sector. The construction of wind farms involves complex foundation work, followed by precise turbine assembly. Hot Mix Asphalt HMA paving quality control process focuses on paving operations, covering surface preparation, material handling, paving equipment procedures, and quality inspections. Prior to paving, the underlying surface, whether a newly constructed base, repaired concrete, or milled asphalt, must be clean, free from debris, and swept using mechanical brooms or vacuum trucks, especially in urban areas. All cracks, joints, and surface irregularities must be blown clean using compressed air. A tack coat is then uniformly applied to enhance the bond between the existing layer and the new HMA lift. Transporting HMA from the mixing plant to the site requires strict temperature control. The mix must be delivered at temperatures above 250 degrees Fahrenheit and within plus or minus 20 degrees Fahrenheit of the target mixing temperature. Trucks must be clean, tightly sealed, and covered with tarps to prevent heat loss. Diesel fuel must not be used as a release agent, as it compromises the asphalt's performance. Upon arrival, trucks are carefully guided to the paver to prevent mechanical damage or surface disturbance. The paving process typically includes base, leveling, and surface lifts. The paver must be equipped with an automatic screed control system that adjusts transverse slope and elevation according to the design profile. Paving begins at the butt joint, and the screed must be preheated to prevent material buildup and ensure a smooth mat. Paving speed must match the output capacity of the asphalt plant, and the availability of delivery trucks to ensure continuous operation and avoid surface irregularities due to stoppages. During paving, the HMA is fed into the paver's hopper, conveyed by slat conveyors, and passed through flow gates that control the material quantity before reaching the auger. The auger distributes the mix uniformly ahead of the screed. Ultrasonic sensors monitor and adjust material levels to maintain consistency. Longitudinal joints between adjacent paving lanes are constructed using either a tapered joint or a vertical butt joint. The tapered joint typically extends at a 12:1 slope ratio. In echelon paving, two pavers work side by side to eliminate cold joints and produce a more homogeneous mat. Final inspection focuses on key criteria such as mat thickness, slope, grade, surface texture, compaction, and overall geometry. All delivery tickets, temperature logs, and test results must be meticulously recorded to support quality assurance and eventual acceptance. Through proper coordination of material logistics, equipment operation, and quality control, the HMA paving operation ensures a durable, smooth, and structurally sound pavement layer. RAK Ports embarked on a comprehensive expansion initiative aimed at enhancing the operational capacity of RAK Port, located in Ras Al Khaimah, United Arab Emirates. As the largest bulk handling port in the Middle East, RAK Port plays a critical role in supporting the regional economy by facilitating the export of raw materials such as limestone, which is quarried extensively in the adjacent mountainous areas. Prior to the expansion, RAK Port consisted of 8 bulk berths with a maximum depth of approximately 12.2 meters, accommodating vessels up to Panamax size. However, increasing demand for bulk cargo handling, which had reached over 70 million tons annually by 2018, necessitated the upgrade of port infrastructure to accommodate larger cape-sized vessels. These vessels require significantly deeper drafts, approximately 18 meters, as well as longer quay lengths for efficient berthing and cargo operations. The core objective of the expansion project was to construct 2 additional berths capable of handling cape-sized ships, thereby increasing the port's throughput capacity by approximately 50% and ensuring its competitiveness in the global bulk shipping market. The engineering challenge involved the design and construction of one of the world's tallest and deepest quay walls within an exposed offshore environment lacking natural sea protection. The project scope encompassed dredging an approach channel, a vessel turning basin, and the new berth area to the required depths, totaling roughly 1.3 million cubic meters of seabed material. Additionally, reclamation of an 85,000 square meter land platform was carried out between the new quay line and the existing breakwaters to provide operational and storage areas. The quay wall itself was designed to reach heights exceeding 26 meters above the seabed to withstand severe wave loads, tidal forces, and vessel mooring impacts. Ensuring a stable foundation required extensive geotechnical investigations to characterize seabed stratigraphy, which included layers of silt and weak soils that necessitated ground improvement techniques and deep foundation elements such as driven piles or rock anchors. The construction process involved the fabrication of over 5,000 specialized concrete quay blocks, each weighing approximately 80 tons. These blocks were cast using a tailored concrete mix, designed to achieve high durability and strength, in a marine environment subjected to thermal variations exceeding 40 degrees Celsius during the casting period. To optimize curing and reduce thermal cracking risks, casting was scheduled primarily during nighttime hours. After curing, the blocks were transported by barges to the construction site, where precise underwater placement was achieved using heavy-lift crane barges, coordinated with diver teams equipped with advanced underwater survey and positioning technology. These operations required stringent safety protocols due to the heavy loads and variable sea conditions, as well as continuous environmental monitoring to ensure minimal impact on local marine ecosystems. Environmental management was a critical component of the project. Comprehensive baseline surveys, including marine ecology assessments, were conducted prior to dredging and construction. Mitigation measures, such as coral colony translocation, were implemented to preserve sensitive habitats affected by dredging activities. In addition, sediment control measures were applied to minimize turbidity and protect water quality. Wave monitoring buoys provided real-time data to adjust construction schedules in response to adverse weather conditions, ensuring both safety and environmental compliance. Project management and coordination played a vital role in the successful execution of the expansion. Jacobs Engineering served as the lead consultant, responsible for detailed design, construction supervision, and environmental oversight. BAM International, the primary contractor, utilized specialized marine construction equipment and leveraged extensive expertise in heavy civil works to maintain project momentum despite challenges posed by harsh offshore conditions. Integration of geotechnical data, Metotian modeling, and advanced construction techniques allowed for optimization of design parameters and resource allocation. Upon completion in 2019, the expanded SAC port was able to accommodate the largest bulk carriers in the world, significantly increasing throughput capacity and reducing vessel waiting times. The project not only strengthened SAC Port's strategic position as a key bulk cargo hub in the Middle East, but also demonstrated successful engineering innovation in the design and construction of deepwater quay infrastructure within a demanding marine environment. This expansion provides a scalable foundation for future growth and enhances the overall operational versatility of the port. Some infrastructure projects require unconventional approaches, especially when dealing with challenging environments. At Levi's 49ers Stadium, a seismic expansion joint system, SJS, was installed to ensure structural flexibility and durability. All materials were custom fabricated based on precise field measurements. The joint material was laid beside the target location, while a grinder or wire brush was used to clean the substrates, removing protrusions and debris. After wiping the joint faces with solvent, epoxy was mixed and applied. The pre-compressed joint material was then unpacked, edges wiped, and inserted into the joint gap. Sealant was applied at the joint intersections, followed by the injection of sealant bands on both sides at 3/4 depth. Sealant was tooled into a corner bead for water tightness. Since the material begins expanding as soon as it's unwrapped, the installation team had to work quickly and precisely. Screws were driven into the self-tapping channel for secure anchorage. Polystyrene concrete blocks are lightweight construction elements made by blending cement, sand, water, plasticizer, latex, 5 kg per cubic meter, and foamed polystyrene granules sized between 5 to 7 millimeters. The water content is typically 1/3 of the cement volume, and the plasticizer is added as per the manufacturer's guidelines. The polystyrene concrete mixture is prepared and cast directly on site using a practical application method known as cast technology. Polystyrene granules, known for their thermal and acoustic insulation properties, are also widely used in agriculture as soil aerators and in the furniture industry as lightweight filling. The mixture is poured into place and allowed to cure under natural conditions. Topping applications are performed as a single layer on floors and inclined surfaces, up to 12 degrees, providing insulation and load distribution. For large-scale roof applications, the polystyrene concrete mixture can be dispersed using a pump, improving installation speed and efficiency. Restoration of the Canal, situated approximately 20 meters below the groundwater table, required a specialized underwater rehabilitation method due to the impossibility of conventional dewatering techniques. Standard practice involving full canal sealing and excavation was not applicable. A custom fabricated platform was engineered using AutoCAD based on precise canal cross-sectional profiles. The platform dimensions were approximately 35 meters in length and 1.25 meters in width, assembled off-site and transported for on-site deployment. The total operational length exceeded 40 meters with a structural mass of roughly 40 metric tons. The rehabilitation process utilized a crane system equipped with hydraulic articulated joints, allowing multi-axis maneuverability necessary to navigate the canal's curvature. Reinforcement mats were deployed along the canal bed at an approximate 13 degrees gradient. Concrete was pumped underwater into the mats via gravity flow, ensuring uniform consolidation and a seamless lining. This method permitted continuous underwater placement without dewatering, maintaining structural integrity and reducing environmental disruption. The hydraulic platform enabled precise positioning and alignment corrections throughout the procedure. Innovation isn't just about new construction. Sometimes it involves dismantling old structures safely and efficiently. The Ehrenfeld-Wittefeld wind farm in Bromsha is a complex and highly coordinated process involving multiple construction phases. It begins with the preparation of access routes and groundwork, where the soil is leveled and compacted. Empty conduits, known as Leerrohre, are laid to accommodate future electrical and communication cabling. With the subgrade prepared, the construction of the turbine foundations begins. Formwork is installed to define the concrete structure, and 85 tons of reinforcing steel are carefully arranged within the molds. The upper part of the foundation is then poured with approximately 1,100 tons of concrete. Following the concrete pour, a curing period of 28 days is required to ensure structural strength. During this time, backfilling is carried out around the cured foundation, and staircases are installed inside the base to allow future access. Simultaneously, the underground electrical cable route is laid out, connecting each turbine location to the main substation. The tower construction phase follows with the delivery of massive precast concrete segments, requiring around 40 heavy transport vehicles. A 500-ton crawler crane with a lifting capacity up to 90 meters is assembled on site to lift each concrete segment into place. These segments are stacked vertically using a precision working platform. The concrete portion of the tower is typically completed within 15 days, reaching a height of approximately 88.6 meters. Once the concrete tower is complete, two steel tubular sections are installed at the top, each weighing about 50 tons. The nacelle, which houses the generator and drivetrain, is lifted using a 750-ton crane with a reach of up to 145 meters. An auxiliary crane supports this operation. After the nacelle is installed, the main drive shaft and internal components are positioned. The three rotor blades, each measuring 59.8 meters in length, are then attached sequentially to the hub. Once all components are in place, final adjustments and testing are conducted. Each wind turbine reaches a hub height of approximately 139 meters, with the rotor blade tips extending to a maximum height of 199 meters. The entire process, from groundwork to the final installation of the rotor blades, takes several weeks and involves meticulous planning, safety measures, and logistical coordination. The assembly of the turbines is a dramatic and awe-inspiring event, especially during the rotor lift, which often draws attention from onlookers as the massive structures come to life. The completed turbines are then connected to the grid, marking the transition from construction site to renewable energy production facility. The light-cast underfloor heating system, combined with main core technology, delivers superior energy efficiency for modern floors. Installation starts with edge insulation placed around the walls. A foil-faced membrane is laid to prevent concrete leakage, and the floor is sealed with tape. The manifold is set in its correct location, either permanently or on a temporary frame. Pipe-free zones are marked, and PMP pipe lengths are selected and fixed to the manifold, ensuring no in-floor joints. The pipes are laid at designated centers, insulated where needed, and secured using staples. On ground floors, infill blocks support the system. The start and end of the pipework intertwine to ensure balanced heat distribution. After filling the system with water, a pressure test to 4 bars is conducted. Finally, a 75 to 80 millimeters fiber-reinforced concrete topping is poured, leveled, and hardened, creating a strong, heat-efficient floor base. The SPIDE REXK8 system is a high-performance external thermal insulation solution designed to improve energy efficiency, protect facades, and ensure long-term durability. Its multi-layered installation process combines advanced materials with precise execution techniques to deliver superior results in both residential and commercial buildings. Below is a step-by-step outline of the installation process. The process begins with the installation of RXZ base panels, designed specifically for the lower part of the facade. The first panel is positioned carefully, ensuring it is aligned properly with the designated baseline. Once aligned, mechanical drilling is performed, followed by secure anchoring using approved wall plugs to guarantee panel stability. Subsequently, the RXL insulation panels are positioned and mechanically fixed above the base panels. With the thermal insulation layers in place, a bonding plaster layer RXM1 is applied over the surface to ensure proper adhesion and preparation for reinforcement. Guiding profiles and RXP corner beads are then installed to define edges and provide impact resistance. Afterward, a base coat RXM2 is applied over the entire surface, ensuring it is evenly spread and reinforced where necessary. The wall is then leveled using screeding tools, and final adjustments are made to perfect the surface, ready for the finishing layer. Seamless stamped concrete molds are specially designed tools used in decorative concrete applications. These molds create realistic textures and patterns such as stone, brick on fresh concrete surfaces without visible seams or joints. Ideal for garden walls, pathways, patios, or landscaping projects, these stone-textured molds help achieve a natural and elegant appearance. Made from durable polyurethane or hard plastic, they are reusable, easy to clean, and ensure long-lasting performance. The process involves pressing the mold onto freshly poured concrete to imprint the pattern. These molds offer high flexibility in design, with various sizes and textures available to suit different project needs. They are especially useful in wall cladding, boundary fencing, outdoor paving, and retaining wall decoration. Stamped concrete molds not only enhance aesthetic appeal, but also reduce surface maintenance by providing a durable and weather-resistant finish. With seamless technology, users can avoid pattern interruptions and achieve smooth, continuous textures. A cost-effective and eco-friendly solution, these molds require no additional paint or sealants and minimize waste during construction. Perfect for both residential and commercial applications, they are a modern solution for adding style and structure to any concrete surface. A fascinating look at 3D concrete printing experiments conducted at Eindhoven University of Technology. These trials showcase the innovative potential of additive manufacturing in construction. Using specialized concrete mixtures and robotic arms, the team printed complex shapes with impressive precision and structural integrity. This cutting-edge technology could revolutionize building methods, offering faster, more sustainable, and customizable solutions for future architecture. From walls to entire structures, 3D concrete printing pushes the boundaries of what's possible in modern construction, blending engineering and digital design like never before. Tasmatic ground paving mold is a practical tool for creating personalized garden walkways and decorative paths with ease. Made from durable, high-quality plastic, the mold measures 40 by 42 centimeters with a 4 centimeters thickness. It allows users to design custom paths, sidewalks, or entranceways without the need for professional help or expensive decorative stones. Simply pour concrete into the mold, level it, and lift to reveal uniquely patterned stones. Ideal for enhancing green spaces, garden paths, or building entrances, this tool supports creative designs in various colors and sizes. Easy to use, reusable, and cost-effective for DIY landscaping projects. RAK is a modular system used for the construction of reinforced concrete walls, such as those found in silos. The process begins with the installation of foundation blocks, ensuring a stable base. Next, anchoring stirrups are positioned to provide structural reinforcement and integration with the wall system. RAK blocks are then laid in successive courses, forming the hollow structure of the wall. During assembly, horizontal and vertical reinforcing bars are inserted into the cavities of the blocks according to structural specifications. These reinforcements ensure high compressive and tensile strength, making the wall suitable for heavy-duty applications such as grain or material storage. Once reinforcement is complete, the entire wall is filled with concrete, locking the structure together into a monolithic, durable system. Step-lock enables fast, accurate, and efficient construction with minimal formwork requirements. The MT360 roadheader is a versatile tunneling machine designed for efficient rock and soil excavation. Equipped with a rotating cutting head, it continuously removes material while maintaining precise alignment. Its robust conveyor system transports excavated material out of the tunnel, ensuring uninterrupted operation. Ideal for mining, civil works, and underground infrastructure projects, the MT360 delivers high productivity and reliable performance.